Good morning students, I am Sweetly, Assistant Professor of Civil Engineering Department working in Emmanuel G.T. College of Engineering. Today we are going to study how to calculate the stresses. The question is, a steel rod of 20 mm diameter passing centrally through a copper tube of 50 mm external diameter and 40 mm internal diameter. The tube is closed at each end by rigid plates of negligible thickness. The nuts are tightened lightly on the projecting parts of the rod. If the temperature of the assembling is raised by 50 degrees Celsius, calculate the stresses developed in copper and steel. Take E for steel and copper as 200 giganewton per meter square and 100 giganewton per meter square, and alpha for steel and copper as 12 into 10 power minus 6 per degree Celsius and 18 into 10 power minus 6 per degree Celsius. In the question they give the diameter of steel rod, then for copper they give both external diameter and internal diameter. Therefore, first we are going to note down the given data. The diameter of steel rod is mentioned as ds equal to 20 mm. Then external diameter of copper capital D equal to 50 mm. Internal diameter of copper small d equal to 40 mm. Then the temperature of the assembling is raised by 50 degrees Celsius. They asked to find out the stress when the temperature is rising by 50 degrees Celsius. Therefore, the temperature is given as 50 degrees Celsius. You mark the temperature as T equal to 50 degrees Celsius. Then we know that capital E denotes the Young's modulus. Young's modulus for steel as well as copper value is given. Therefore, Young's modulus for steel, capital E suffix S represents the steel. Es equal to 200 giganewton per meter square. Therefore, you have to convert the value in Newton per mm square. Giga, we multiply 10 power 9. Then to convert meter to millimeter, we know that 1 meter equal to 1000 millimeter. Here in the denominator we have meter square. Therefore, 10 power 3 the whole square, which means 1000 the whole square. After cancelling, we get the value for ES as 200 into 10 power 3. Similarly, for Young's modulus of copper, the value is given as 100 giganewton per meter square. E suffix C represents the copper. E represents the Young's modulus. Therefore, EC equal to 100 giganewton per meter square. Giga we convert into Newton. Therefore, 1 giganewton equal to 10 power 9 Newton. 10 power 9 divided by meter to millimeter conversion, 1000 square, that is 10 power 3 the whole square. After cancelling, we get 100 into 10 power 3 Newton per mm square. Alpha means coefficient of linear expansion. For steel, we denote alpha S equal to 12 into 10 power minus 6 per degree Celsius. Then coefficient of linear expansion for copper, alpha C equal to 18 into 10 power minus 6 per degree Celsius. In the question, they asked to find the stresses in copper and steel. Therefore, we indicate the stress as alpha. Therefore, alpha S and alpha C we have to find out. We all know stress means load by area. Here, load value is not given. Instead of Young's modulus, coefficient of linear expansion, diameter and temperature value is given. Therefore, we have to use the formula for axial expansion. We all know the formula for axial expansion is alpha T plus or minus sigma by E. In the question they give alpha T and E. From that we have to find out the stress value sigma. Therefore, first step we are going to calculate the area. Area of steel AS equal to pi ds square by 4. Normal area formula, area of circle pi d square by 4. Here we are using the steel material, therefore we represent as A suffix S equal to pi ds square by 4. Pi ds value is given as 20, therefore 20 square by 4, the value is 314.15 mm square. Unit for area is meter square or mm square. Here we substitute the diameter value in mm, therefore the unit is mm square. Same like that, area of copper. Here they give both external diameter and internal diameter for copper. Therefore, the formula becomes pi capital D square minus small d square by 4. The value is given. For capital D, the value is 50 mm and for small d, the value is 40 mm. Substitute the value, we get the Area for copper AC equal to 706.85 mm square. Then for equilibrium system, load on steel is equal to load on copper. Same like that, axial expansion in steel is equal to axial expansion in copper. Therefore, load is calculated from the relation stress is equal to load by area. From that, load equal to stress into area. Therefore, load on steel equal to stress sigma S into AS. Load on copper equal to sigma C into AC. From that, sigma S is equal to AC by AS into sigma C. AC and AS value is already we find out. Substitute that value and make sigma S is equal to 2.25 sigma C as equation 1. Then using the relation axial expansion in steel equal to axial expansion in copper, the formula becomes sigma ST plus sigma S by ES equal to alpha CT minus sigma C by EC. The value for alpha S and T is given. Sigma S is equal to, we find out 2.25 sigma C, substitute that value. Then substitute the value for Young's modulus. Same like that, substitute the value for alpha C, T and EC value. Then simple calculation, we want to calculate the sigma C, therefore keep the sigma C terms in the left hand side and other values in the right hand side. From that you have to calculate the sigma C value. The unit for stress is Newton per mm square. Then substitute the sigma C value in the equation number 1, that is sigma S is equal to 2.25 sigma C. Then we get the sigma S value. Thus we obtain the stress in steel and copper. Thank you, students.